Ladies and gentlemen, I'm glad to welcome you here on our CoffeeJUG online event. Today we will listen to and watch presentation from Rafael Benevides. Sorry, Rafael, Principal Product Manager at Oracle. Yeah, I trained your last name for multiple times, but still made a mistake. And yeah, we will listen today about the tracing cloud native applications. But before we start, I will briefly tell you about our event. CoffeeJUG is a regular event related to Java and the ecosystem. We have both online and offline events. Today is our event number 31, and we have already around 500 participants, both offline and online. Here you can see our people who actually make this event happen. Andrei, Remar, Uliana, and Igor. And we have also a program committee, the people who make sure that the presentations are the best quality and are as good as it is possible. So they review the presentations and help our speakers. And here are our partners, Avanga, Sombra, and Grid Dynamics. And also a community partner, JetBrains. We will actually give you out some JetBrains licenses after the talk if you will provide feedback, if you will fill in the feedback form, and if you will be lucky enough actually to get this license according to random.org. A couple of words about our social responsibility. So we are partners of a charity organization called IT Mykolai. For those who are not from Ukraine, I will briefly explain what is this organization. So is like a Santa Claus in Ukraine, and he was a person who did a lot of good stuff. Especially for school children, and IT Mykolai is a organization which does some good stuff for children, especially those sick with cancer. And for many years, this organization collects money mostly from IT companies, but not only, and from software engineers, but again, not only. And they buy equipment for Ukrainian hospitals where children with cancer are treated. So in the chat, you will get a link to more details about what exactly equipment would be purchased for money you will donate, hopefully, or you can use this QR code to navigate to this page from your phone. So please welcome and join this charity event. And for those who will be the most active today, we have a bonus. We will give you out a coffee and a croissant. We will contact you after this presentation to determine how to do that actually. Please join us in our social media, our Facebook, Twitter, and Telegram channels. And that's all about what I had to say about CoffeeJUG. Now I'm switching off my microphone, and Rafael, please welcome, and I wish you a good presentation.
It's a pleasure to be here talking to you again. And I say it again because I was in Ukraine twice. So the last time I was in Kiev for a conference. Of course, I missed those times, but unfortunately, this time needs to be online. But hopefully, I will meet again with all the Ukrainian people in the next conference, maybe next year, who knows. Uh, I know that a lot of people ask about the slides, and the slides are already available in this URL. If you go to bit.ly/CNCF Opentracing, you can access these same slides that you are watching here. Okay. By the way, this is a good moment for you to go also to Twitter. My handle is Rafa Bene, and you can click follow. You can mention that you are watching. You can share this presentation. Feel free to help the community to know more about distributed tracing. Okay. As it was mentioned, my name is Rafael Benevides. I work at Oracle as a product manager for a product called OLCNE, Oracle Linux Cloud Native Environment, and everything related to applications and developers platform. Okay, so let's go. Let's understand what happened in the past, a long time ago in a galaxy far away. Well, at that time, oops, at that time there was no DevOps practice, right? So what happened is that developers just threw the jar files on the head of the operational people, usually on a Friday, and said goodbye, I'm going home. And the operational people had to work during the weekends to uh, to put the Java application on production. And that was nice while the application was up, running, happy, serving all the requests. Okay, but that was fine until this site goes down. If the website goes down, it seemed the end of the world. Everybody started to scream, what is happening? Why my application is down? We cannot lose sales. We cannot lose our customers. And it was a panic, a general panic, right? But what the people in the operations said is that they had the control, they had monitoring, they were able to see in a screen a red light saying this application is offline. Of course, that does not solve the problem. Of course, it just points that there was a problem, but it does not solve the problem. So the developers usually were called, and they were told, developer, we have a problem, fix it. And the developer does not know what was happening, and he says, what does the log show? Right? That the first thing when an application goes down, the first thing that we developers do is watch the logs and say why the application failed. Okay, at that time, because there was no DevOps practice, developers didn't have access to the log, and when he asks to operational people, what does the log show? What the operational people say is just a bunch of screens. Imagine someone who is used to operate a Linux terminal and see a stack trace, a Java stack error stack trace. He will not understand. So in that case, developer uh, asks, so if I can't access the log, just show me the logs, because I, as a developer, can understand the logs. And when the developer starts to analyze the log, don't worry about this stack trace. The fact is that when the developer analyzes a stack trace, he feels just like Neo in the Matrix. He's able to see more than a bunch of characters. He's able to see what methods have been invoked, what caused the operation failed and why it failed. Okay, so developers feels just like Neo in the Matrix. But now back to the present. Fortunately, we have the DevOps practice as something very important. Now, developers and operationals, they don't work separated. They work together. There is no more wall of confusion. They work together to make sure that this software is stable at the production. But there are things that never change. Other things changed a lot. Like, for example, the architecture in all these years changed a lot. We used to deploy monolithic applications. Now we deploy microservices. And one thing about microservices is that it's not deployed in a single server. These microservices are spread on different services, creating a network of services. Okay, and so this is a big difference from what used to be. In the old school, we had a monolithic application connected to a single database, and that was it. Now, in this new school, in this new world of microservices, we have different moving pieces, each one of them connected to its own databases, to its own database, running on top of containers managed by a Kubernetes cluster, right? So things changed a lot, but as I said, there are some things that never changed, and operational people saying that they still have monitoring is one of those things, right? So they say that they have monitoring. Nowadays, we don't call it monitoring anymore. What term do we use? We use the term observability. Why observability? And I like this Twitter from Cindy. Cindy said, observability because developers don't like to do monitoring. So we need to package the monitoring, in a new nomenclature to make it palatable and trendy, right? So well, the term monitoring now became observability. But observability is more than monitoring. It's composed of three pillars of observability. There is the pillar of metrics, where we will provide, the application will provide metrics like number of requests, CPU usage, memory usage, and so on. Number and time of garbage collector, any time of metrics. We have the pillar of logging, where we will analyze the log of all the microservices, and in this term we can think in a stack of ELK, Elasticsearch, Logstash, and Kibana, or EFK, Elasticsearch, FluentD, and Kibana. And we have the pillar of tracing. And the focus of this presentation is all about tracing. We will learn how to do tracing in cloud-native applications, especially Java applications like Microprofile and Spring Boot, okay? Of course, integrating that with other languages like Node.js. I have a demo that shows an application using Microprofile, Spring Boot, and Node.js, and how they can interoperate, because that's the idea of cloud-native applications. It's not tied to any language or to any technology or Java framework, okay? So let me start with a question to make us think why tracing is so important. If you look at this diagram, can you describe what is the invocation order or the latency? How long does it took to perform all these operations, or the billing? How long it took to perform the billing? Or suppose that here the client receives an HTTP error 500. Who caused an error? Suppose that you don't treat that error. It is propagated from the lower layers to the top layer of the client. Who called her? It's hard to understand unless you change this diagram in a timeline view. We just switch that in a timeline view, and we can see all the time that that was spent in the client transaction from start to end. Then we can see all the time spent in the load balancer, in the authorization, in the billing, and we can see that the resource allocation and provisioning took half of the time of the whole operation. Why? Because it took some milliseconds to do the container startup, storage allocation, and the startup script. So if we are trying to understand why my application is slow, we need to understand how long each operation took. Okay? So continuing understand why do we need tracing? In that network of services, we need to understand the critical path for a microservice, because a microservice A can invoke a microservice B that can invoke microservice C, X, Y, Z, right? And if a microservice fails, why did it fail? Who failed? Okay, and why is it slow? Why the latency is slow between this microservice and this microservice? So tracing answers all these questions. Okay. And to perform tracing is nothing. It's not new. In fact, it's an old practice. But given that microservice needs to interoperate between, as I said, different languages, different frameworks, different technologies, there was a need to create a specification that will address this incompatibility between different distributed tracing systems. Okay, so the Opentracing is as a specification that has no relation with any platform or vendor. And by the way, it's part of CNCF, the Cloud Native Computing Foundation. So it's managed by CNCF in a way to create, to specify how cloud native applications will perform distributed tracing. Okay, to understand distributed tracing, we need to go through some terminologies. What is a trace? What is a span? What is a log? What is a tag? What we will do now is understand all those terminologies. The first one is a trace. So what's a trace? A trace is the click on a button. When you click on a button, it will spawn a lot of operations, right? It can call 3 or 10 or 100 microservices, but that will be a single trace. Okay, it will cover the entire request of service that is included in that request. Okay. So what's included? So as I said, the trace is also a collection of spans. What is a span? The second terminology. A span is basically an operation. So and as an operation, it has the name of the operation. It has a timestamp where it started and when it finished. The tags, the logs, and also a reference, a relationship with other spans. Because one operation can call another operation in parallel. So one operation can have two children's of operations in parallel. So you can have a relationship of the kind child of. You can have a serial invocation where one microservice calls another that calls, and that's a follows from relationship. So it's a difference between child of and follows from is that child of it's parallel, follows from is a serial invocation of operations. Microservice A calls B, calls C, calls D, and so on. What do we also have in span? We have logs. Span logs, they are different from logging, right? The idea is not write the logs in the terminal, but to to write in the operation, in the distributed tracing, what is that operation doing? Okay, so it's composed of key value pairs where you just can say, like, for example, message, opening a connection to my SQL server, or another log, message, connect to my SQL server. Those two are example of logs. We have also the concept of tags. Tags is also key value pairs, and the difference between span logs and span tags is that tags, they follows a semantic convention. So let me open here the semantic conventions for logging. Okay, let me increase the font size. This is part of the Opentracing specification. And you can see here that we have some conventions. What's the name of the component? What's the instance of the database or the statement that you sent to the database? The error, which is Boolean, true or false. Tags about the HTTP method, status code, URL, and so on. So this is predefined information that you can place on logs, okay? So examples, DB instance, DB statement, DB type, HTTP method, HTTP status, HTTP URL, and so on. We have also the concept of baggage. Baggage is also key value pairs, but they are not tied to a span. They can cross the process. It can go. I can place an item in a baggage, and a baggage you can imagine just like a bag. You can or a backpack. You place an information on this baggage, and this baggage will be carried across other spans, and you can consume what was placed in that baggage later. Okay, so that's the idea of a baggage. So here you can see everything that I said about a span. So a span has a name. In this case, the operation name is DB query. We have a start and we have a time for an ending, how long it took, the whole span. We have tags, which is predefined, DB instance. So the name, DB query. So we know that's a database query. So the DB instance is customers. The DB statement is select from my table where foo equals bar. The peer address, where is this database running? So it's a MySQL running localhost port 3306/customers. The log message says can't connect to my SQL server. So this query was not successful. And we have the context of this span. Who is the parent trace ID? Remember, when we click a trace, it will create a collection of spans because it will touch a lot of operations. 1, 2, 3, 4, 10, 100 of operations, 100 of spans. They are child of a parent trace ID. We need the ID of this span, and we can place baggage items. Okay? What about Jagger? So we saw that Opentracing is a specification, just like Jakarta E, just like microprofile. Jagger is an implementation of Opentracing. It's inspired by Dapper and OpenZipkin. If you have worked with Spring Cloud, you might have used Zipkin before. So Jagger is just like Zipkin. It became open source by Uber. Opentracing, Jagger provides it's compatible with Opentracing, right? And it provides libraries for Go, for Java, for Node, for Python, and for C#. So this is the overall architecture of Jagger. If you want to use a Jagger, if you want to use Jagger in your application, suppose that you are building a Java application, you will use a Java library, a Jagger client library for Java. If you are using Python, there will be a Jagger client in Python, or for Go, or for Node, or for C, or even PHP and Ruby with a limited, with some limited features. Okay. This Jagger client will send the spans. We saw what is a span, right? It will send the spans through the UDP protocol to a Jagger agent. The Jagger agent will push the spans to a Jagger collector that will perform adaptive sampling. It will control how many requests do I want from the Jagger agent. 10%, 50%, 100%. So it will adapt how many samples you need and store that in a database. This database is maintained by Spark jobs, okay? And then you have a Jagger query UI that provides a UI so you can perform queries and see how your application behaved, okay? I mentioned Zipkin for those who use Spring Cloud, and you might ask, why Jagger over Zipkin? Zipkin is also compatible with Opentracing, but I found this blog post here that compared both Opentracing distributed tracers, and it says something that's very important. Despite Zipkin being around for a while, longer and being more mature, Jagger has seen some good adoption thanks to several factors such as a good language coverage of Opentracing clients, as we saw. Java, Python, Ruby, C#, and so on, C++, and a low memory footprint and a modern and scalable design as we just saw. Okay, so this is why Jagger is getting a lot of attraction over Zipkin related to Opentracing clients, Opentracing tracers, okay? Now, my favorite time, which is the demo time. I have here the first URL, which is the URL of Jagger UI. And I have also another endpoint that will call my application. Note here, I will do a single request, a single trace when I call /serial/Rafael. Okay, you can see that it's working here, and it answered me the following messages. Microservice A, which is my front end, called microservice B, that saved to database, and this is a counter, 0, operation number 0. Microservice A, in the same request, I did one request at a time. Microservice A, the front end, called microservice B to save in this message in Kafka. And the microservice A called microservice B that called microservice C hello, and microservice C returns hello Rafael, which is my parameter here. Okay, so this was a single trace. I invoked this in a serial way. Now let's see what happened in Jagger. Okay, let me reduce the font size. And here in the Jagger UI, we can filter by service. Let me refresh here. By service, all the services that that it has information, microservice A, B, and C. I can filter by tags. Remember, they follow a semantic convention. I can see what happened in the last hour, last 2 hours, last 2 days. With minimum duration or maximum duration, and limit the number of results. Before I show what happened, I can also see the dependencies and a diagram of invocation. So I see that my microservice A invoked 3 times, as we can see here, invoked 3 times the microservice B, and my microservice B invoked my microservice C once. Okay, so we see that based on what my application did, it designed it to me automatically the diagram of invocation. But now let's see what are the informations that we have. We have a previous request here 2 minutes ago. Okay, let's not consider this one. Let's get the first request that I have here. where microservice A invoked microservice B that invokes microservice C. If I open this trace, there is a collection of 25 spans. So let's open these spans. Here I can see everything that happened to my application. So I received a request in the Helidon web server. So the HTTP status code was 200. My URL /serial/Rafael, as you can see here, right? Oops. And then it touched my application. There was some interceptors here, and it took like 2 seconds to complete the whole operation, right? You can see here, 2 seconds and 31 milliseconds to complete the operation. And why it took so long? Because there was 1.65 seconds that took to call the microservice B. So you can see here details about it. The IP, the internal IP, we can see the tag, internal span format. So it's proto means it's just code. It's not a database. It's not a client or a server of anything. Then we have finally this operation to call the microservice B. We have a span kind client. It is the microservice A is a client of microservice B. So it will call the microservice B in the port 8080/db/Rafael. So the microservice B will receive the request. So the span kind now is the server. So we need a client and a server, so they are connected. We have logs here, which is a pre-handle log from this endpoint. And then it will call what? My database. And note here that how deep I can go in a tracing. I can go, trace JDBC connections. It's mentioning that I went to a MySQL database running on the port 3306. So the DB type is MySQL, and the base DB statement is select next vol from Hibernate sequence for update. And then there was another update, another database operation here, update Hibernate sequence, and finally insert into the table message values that was received by this query. So we can go deep to trace even network database requests, and all of them took, like, let me see, just 180 milliseconds. Okay, it was very fast. Now there was then microservice A called microservice B again, right? So we can see here the client invoking the server in this endpoint, Kafka/Rafael, and we can also trace the Kafka operations. So we can see here that the message has been placed inside Kafka in a topic called my topic, and I act my microservice B act as a producer. If I was consuming a message, it would say that the span kind was a consumer for Kafka. And finally, it called microservice C. And I have also some parameters here, some logs that request received, or the event was hello with the parameter Rafael. So I'm totally able to trace my operation. If you didn't, without looking to the answer of my application, I'm able to see that uses MySQL, that uses Kafka, what was the operation, that uses Hibernate, and everything related to the overall architecture, that the microservice C uses Node, without without looking at the source code of the application, right? Now let me do something even more. I will stop I will stop the MySQL database, right? We can see that it will stop here, shutting down complete, and I will invoke again my microservice, right? Note here, when I invoke, I received an HTTP error 500. Okay, 500 does not tell me more than it happened an error. But if I open the trace, I can see here that microservice A already failed, right? And why I'm not seeing B and C? Because microservice B is still trying to acquire connection. Microservice A failed because of a timeout. We can see that it's failed. Let me see here. We can say that that's marked with an error, right? We saw the error here. We saw the HTTP that the server error HTTP status code 500 has been raised. We can see who threw this error, because the last operation here was this one. We can even see the error in the log. It was a processing exception. And as I said, microservice A failed first because there is a timeout. But it does not mean that there will be a moment where microservice B will throw the error as well. So let's see the Jagger UI. Yeah, microservice B raised the error now. So microservice B reported the span, and we can see now the calls from the other side, from the server side, from the microservice B side, that when I tried to invoke this microservice B, it logged also an error. You can see here that error true, and the message, the complete stack trace is here, and I can see that MySQL name or service not null. So in a distributed application where we have 100 of microservices, having a distributed tracing is very important to help debugging the application. So let me start the MySQL again. MySQL is running. Let me invoke the application. Everything is working. If I find the trace, now everything is working again. Okay. Now that we understood why tracing is important, how it works, let's understand how we as developers can use Opentracing in our Java application. So the first thing that we need is the tracer object. So we need to instantiate a tracer. There is different ways to get the tracer based on the language, based on the frameworks. If you are using Spring, if you are using microprofile, there will be different ways to get the tracer. But once that you have the tracer, if you want to create a span, you will call the method tracer build span with the name of the operation and start active. That will create a span. Once that you have an active span, you can set the tags manually, you can set the logs manually, you can set baggage items, you can get the baggage items. And once that you call span.finish, once that you call the finish method, it will report the spans to the Jagger collector. You might have noticed here, I know that the screen is a little bit tight. It's small, but at the end of the operation, the span is reported. But don't worry about that. I will show the code later. Okay. Now about the you have noticed that when a microservice A calls microservice B, the context is propagated from one to another, and when it calls the microservice C, the same context is propagated. So you have the whole dependency graph in Jagger, right? You can see everything here. So the same context the same span C70s, 6570 has been propagated from A to B to C and so on. How that works? That works using HTTP headers. Okay, so when a client tracer is about to call another microservice, it injects a lot of headers, like for example, XB trace ID, XB3 parent span ID, XB3 span ID sampled in the header. And when the server, the microservice B server receives the request, it extracts those information and propagated the trace context, okay? There's another format. This is called the B3 headers, but there is a format that Uber released, which is called the Uber headers, where the header, the HTTP header is called Uber trace ID, where the trace ID, where you can see the value, where the trace ID, span ID, parent span ID, and the flags are propagated in the same header. So you can see here in the log message, for example, when a span is reported, we see the trace ID, then the span ID, then the parent span ID, and the flags, okay? So this is how it's propagated. Jagger uses the Uber header, of course, because it's provided by Uber. And there is an initiative, because we can see there's two formats of propagating the tracing head, the tracing information between a microservice A and B. And there is an initiative of W3C to create a specification on what headers do we need to propagate a tracing information, okay? So probably this will become part of HTTP specification. Now, regarding Opentracing with Jagger in a microprofile, it can be Quarkus, it can be Helidon, it can be Payara. If you just provide a JAX-RS server, all server traces are traced automatically. Everything that you receive in JAX-RS server is propagated automatically. Okay. Internally, all methods, for example, you receive a request, but internally you call another method. Let me show that in a source code. So let me get the microservice A. I have here a REST resource that calls another method in another service. Okay, to have that method traced, I need to use this traced annotation. Okay, and the context propagation, every JAX-RS client that uses our microprofile REST client, the trace is propagated automatically, right? So you don't need to to use the Jagger API to create the span or to inject the headers or extract the headers. This is done automatically on the JAX-RS server or JAX-RS client or propagation. Method calls you need traced, and asynchronous calls you need to activate the span. You need to get the server span and place it in the asynchronous thread. This is the only gotcha that you might have if you are doing a synchronous call. Okay, let me show you the source code. So if you are doing an invocation in parallel, which needs to be asynchronous, you need to get the server span, okay, and then place the server span inside the completable future supply async method, which is the asynchronous thread. Okay, so that's why we need to activate the server span inside the task. This is the only gotcha. Okay, now suppose that you are using Spring Boot. In Spring Boot, every JAX-RS endpoint annotated with REST controller the traces are served automatically. Internally, method calls Spring does not have the traced annotation. Okay, there is an initiative that we can see here. There was an initiative trying to create a traced annotation for Spring Boot, but it's not closed. It's closed. You can see that I even commented this in 2 years ago. And because there is no support for traced annotation in Spring, we need to use the tracer API manually. Okay, so we need to do tracer build span and the name of span and activate the span manually. Let's see that happening. Let's get the microservice B, source code, Java, my service. So here is because Spring does not have the traced annotation, we need to create the span manually. So tracer build span, just like we saw, tracer activate span, and in the finally keyword, we just call the span finish. Just because Spring Boot does not support the traced annotation. In the other side, if we are using a client to call other microservices, we need to get the REST template and create and set an interceptor for a tracing REST template interceptor. This interceptor will inject the tracing headers in the REST invocation, right? So if we look here, when we want to, let me see. Let me, yeah. So if I want to invoke another microservice, I need to declare an interceptor of the kind tracing REST template interceptor, placing the global tracer. Okay, and asynchronous call, I need to do the same thing. I need to activate the server span in the how can I say, inside the asynchronous call. Okay. Well, what about Opentracing with Jagger database? There is a project inside this Opentrace contrib organization that provides a lot of contributions from the community for the Opentracing ecosystem. One of them is the Java JDBC. And the only thing that you need to know is to declare as a driver for your application the IO Opentracing contrib JDBC tracing driver. And in the connection string, you add the tracing in front of the database type. Just that. As you can see here in the application, let me open application properties. The only thing that I need to do is declare the tracing driver for the driver class and place the keyword tracing, and that's it. My application starts to collect JDBC informations for Opentracing. Regarding Kafka, Kafka is also provided by this Opentracing contrib community, where we have a Java Kafka client. We just need to add to instantiate the tracing consumer factory or tracing producer factory using as a parameter the default Kafka consumer that uses a tracer. Let me show that in the source code. You can see here that when I'm creating this producer, I inform the default Kafka producer, and I inform the tracer here. Okay, that's as simple as that. Node.js, this is a Java community, so I will not focus in Node.js. But a good thing that's important to know is that if you want to configure Jagger, it's important to know that there are certain environment variables that allows you to declare what's the service name of your application, what's the sample type, is it constant, is it how many requests I will get, should I report the spans, what's the host for Jagger agent, what's the port for the Jagger agent, and so on. Okay, because sometimes if you are running locally, just like I'm doing here, I'm using I'm running all these microservices running on with Docker Compose. So you can see here that I declared the name of the microservice A, said that the protocol is UDP, the host is called Jagger, which is I defined it here, right? And so on for each microservice, no matter if it's a microservice using Spring Boot or microprofile. For Spring Boot, the environment variable changes a little bit, but the concept it's the same. The name of the service, if you will log the spans, where is the Jagger agent? Finally, if you are running Istio, when you are running Istio, the idea of Istio is that for a distributed application, we need discovery, load balancer, resilience, metrics, and tracing. But with Istio, all those features are placed inside a sidecar container. Istio provides an Opentracing implementation with Jagger. Jagger is part of Istio, and everything that get in through the Istio ingress gateway or through the sidecar container is traced. But there is some considerations here if you are using Jagger. This is part of the Jagger documentation, but people don't, really forget. They tend to think that's made automatically. But the Istio documentation says the Istio sidecar proxy envoy generates B3 headers if they are not provided by request. So if you are running on Istio, the only thing that you need to do is, instead of using the default B3 headers, when you are about to deploy in Istio, you should change to use B3 headers instead. Okay? Otherwise, that will not work. And although an Istio sidecar will process inbound and outbound requests automatically for you because of the sidecar container, there is no implicit way to correlate the outbound request to the inbound request. So it's responsible of the developer to propagate the relevant information, the headers from inbound request to outbound request, which it means that it's not only using Istio. You need to do the correlation of B3 headers inside your application, okay? Also, finally, if you want more Opentracing tutorials, there is this link here where you can see resources for C#, Go, Java, Python. With Go here to Java, there are chapters like from the basic Hello World to tracing RPC requests, baggage, and extra credits. This is very nice. The Opentrace contrib that I mentioned has a lot of resources for us, for Java developers, like you can see here. Java Spring Web, Java Spring Cloud, Java gRPC, JAX-RS, benchmarks, Redis, Kafka client used in this demo, JDBC, Spring Jagger, Common, and so on. A lot of resources for us Java developers. And finally, if you want to try that sample application that has microprofile, Spring Boot, and Node.js with Kafka and a database, you can go to my tracing demo at GitHub, okay? This is the end. I would like to, I will open this last 5 minutes to questions, but I'd like to invite everyone here to take this moment, open your Twitter application, look for @Rafa Bene, and click on follow, because there I'm sharing a lot of information regarding cloud native applications, especially Java, because I'm a Java developer, right? And it's a way to keep contact with this awesome community of CoffeeJUG and every other person who is watching this presentation. Okay, so I'm stopping here to know more information regarding the questions, any questions that might have.
Yes, yes, thank you for the presentation. I will try to read all the questions. We don't have too much of them, so maybe you partially or fully already answered this, but I will still read them, and I will ask you to select the best questions so that we can send some kind of prize to the author of this question, okay?
Okay.
Okay, so the first question is from Mr. Dennis. Can I trace a full flow across Kafka, SQS, or Rabbit? And I think the second question from Dennis is somehow related, so I will read it right now, okay? So Service 1 publishes to Kafka. Service 2 and Service 3 listens to Kafka and send messages to queues. Other services continue as queue listeners. Can this whole flow be traced?
Okay, so we have two questions. Let me go by each one. The first question is related to if I can trace Kafka internally, right? I mean by Kafka streams and so on. There's no implementation of that trace Kafka streams. The Kafka client that has here for Java, it just traces the inbound and outbound requests in Kafka as a producer or as a consumer, because it's based on interceptor of these calls. But as if you want to use to trace, for example, Kafka streams, you can manually invoke the Opentracing API to report the tracings. It's here. For example, tracing Kafka client, Kafka provides supplier to Kafka streams config supplier. It's not very clear what it means by this code example, but what I would do if Kafka streams as it's provided here is doesn't work, what I would do is call the Opentracing API myself, get the tracer, and then call all the operations and call span finish at the end. Right? If you want more information, you can post another question. Okay. The second question is related to a flow where where a service calls Kafka. The second service calls, I can remember.
Yeah, the second service listens to Kafka and sends message to some queues, and other services just listen to the queues.
Yeah, that's perfectly fine, because at least this library here watches watch producers and consumers calls in Kafka. So no matter if it's producing or consuming message, it will be traced.
Okay, cool.
And related to the first question, you can see here that it has support for Kafka streams, but I never used. So probably there will be a sample code here.
Okay, cool. So if there are still further questions, I think the author can contact you in Twitter or in YouTube under the video, right?
Right. And again, it's very important to me. That's why I'm hammering this. Click on, go to Twitter, click and follow, because it's part of my job to reach communities. So I will be very thankful to have you following me. And also you can send questions, not only today, but anytime that you want later. We can open a discussion in Twitter. That's very good for the whole community to see what the things that are being discussed related to cloud native application, especially Java.
I think we have three more questions. Mr. Aslum asks, how does tracing work with reactive applications? How do we handle those cases?
Let me see first if there is a library for that. If not, probably we'll need to do a reactor node. There is not. Probably we need to do just like I did for asynchronous call. I needed to get the service span and activate it in the asynchronous thread. So it depends on what how you are performing reactive calls. We need to propagate the service span from one thread to another.
Okay, so the next question is, what happens if Opentracing or Jagger subsystem is down? Will I still have trace ID, span ID be sent in headers without tags baggage stored?
Well, I never tested this, but we can, let me do here very fast. We can stop Jagger. Oops. Okay, Jagger is stopped. Let's perform a call. Of course, it's my application is working, right? Because it's asynchronous calls. Let me do the following here. So hold on a second. Yeah, you can see that in the log that it says span reported, but there's no agent collecting it. Now what we will do is start Jagger. Okay, and let's see what happened to those requests. Find traces. Yes, it seems that I missed the request while Jagger was offline. So that's what happens.
Mm-hmm. And is it possible? It's like my question. You should not vote for it. So is it possible to have some redundancy or maybe some auto scaling?
Yeah, Jagger for when you want to place it on production, because let me show you another thing. When I deployed this Jagger image, it's just an image for testing purpose. It does not store, and the reason that we lose things is it's because it uses the UDP protocol, right? And this image has all in one. But when we are deploying Jagger, for example, on a Kubernetes cluster, there is an operator that will have multiple replicas. There is a database. We can have redundancy. So it's different when we are deploying it on production versus when I'm deploying this on a demo environment.
Yeah, makes sense. Okay, so two more questions. Can I configure Opentracing to use specific header names? I and my company already have some tracing and we want to integrate Opentracing seamlessly.
I don't know. Let's see. Architectures, APIs, client libraries. Let's see client libraries. Propagation format. Trace span. So it supports B3 and the W3C additionally to Uber headers. So let's see. I don't think so. Yeah, I don't think so.
Okay, so the last question for today, does tracing introduce latency?
Nope, because as you can see, it sends asynchronously the information. Okay, so the reporting of spans happens already in another thread. You could see that when I stopped the Jagger, the whole Jagger ecosystem, my application is still saying reporting span reported with zero latency, which means that it was not trying, the application was not trying any connection. It was not facing any timeouts or anything like that. And
Okay.
let's see if that's mentioned here. Make sure client. Oh, FAQ. FAQ. What do I not see? How do I run? No, it does not mention anything related to performance, but there is a performance tuning guide related to Jagger itself, but not related to the application. But let me see another thing here. Well, regarding to the just different languages and different libraries, we can see what are the what libraries supports what headers. So Uber B3 headers is supported by default for all libraries. B3 is supported accepted but C++. W3C is supported only in Java by now. And that's it. And here we have all the environment variables that allows us to configure the clients.
Okay, cool. It looks like a pretty comprehensive answers to the questions. Could you please decide what was the best question? What the question did you like the most?
Wow, that's hard. All of them, people were amazing. But, because I love Kafka and I didn't know about the support for Kafka streams, I'll get the first one that asked about the how if Jagger can trace internal process of Kafka's like Kafka stream. I'll get that one. And sorry, people, for the others. I loved all of questions. Okay.
Yeah, this is the life, right? Even among the equally good things, sometimes we need to choose one. Yeah, so thank you. We will contact the author of the question and we will offer him some small prize. Yeah, Rafael, please stay online. I will just sum up our event for 2 minutes and we'll get back to you. Okay.
Okay.
Evening. Thank you, Rafael Benevides. the principal product manager at Oracle, for delivering this great presentation and answering all the tricky questions, I would say. Just a brief reminder about our partners, IT companies from Ukraine, Avenga, Sombra, and Grid Dynamics. Our community partner, JetBrains. Just a quick reminder about IT Mykolai, the charity organization who take care of kids sick with cancer. Please support this organization and help them purchase some expensive hardware or equipment for the hospitals to treat these kids. We will send our activity bonus to the author of the best question today. And just a brief reminder, join us in our social media, Facebook, Twitter, and Telegram. Feel free to comment out the video in YouTube and join us on our offline events. And even if you are not from Ukraine, just consider visiting Ukraine and Lviv. We will be really happy to meet you here. Thank you for being with us this evening, and have a great evening, and have a nice time before Christmas and good Christmas mood. See you next time.